Heavy industry doesn't begin by building, it begins by breaking things apart. A bridge that stood for decades can be brought down in seconds. A school bus can be torn open like a steel can. A concrete structure can be crushed by jaws delivering hundreds of tons of force. And a machine weighing more than 200 tons may still need an entire transport operation just to reach the job site. But this is not chaos. Every blast, every cut, every crushing bite, and every slow, heavy haul move is part of the same hidden system, controlling force, material, and risk. In this video, we follow the giant machines that break, cut, crush, clear, and move the things too massive for human hands.
Explosive demolition has become one of the most efficient and precise methods for removing large infrastructure such as bridges. Companies like Controlled Demolition, Inc., CDI, specialize in carefully planned explosive demolitions that allow massive structures to be taken down quickly, safely, and with minimal disruption to surrounding areas. A bridge demolition compilation typically showcases multiple projects where engineering expertise and controlled explosives combine to create dramatic yet highly calculated results. Bridge demolition using explosives is a complex process that begins long before the first charge is placed. Engineers and demolition experts analyze the structure of the bridge, including its materials, support columns, load distribution, and surrounding environment. Each bridge is unique, meaning every demolition plan must be customized. Teams often conduct structural modeling and simulations to determine where charges should be placed and how much explosive material is required to guide the collapse in a controlled direction. One of the main goals of explosive demolition is precision. Charges are strategically installed at key structural points, such as piers, columns, and tension members. When detonated in carefully timed sequences, often measured in milliseconds, the explosives weaken critical supports and cause the structure to collapse inward or downward in a predictable manner. This timing ensures that the bridge falls safely within a designated area, reducing the risk of damage to nearby roads, waterways, or buildings. Safety is the highest priority during any demolition project. Before the detonation, large safety perimeters are established, and nearby residents or workers are temporarily evacuated. Traffic is halted, and environmental protection measures are put in place. Especially when the bridge crosses rivers or busy transportation routes. Specialists also monitor dust, debris, and vibration levels to ensure that the demolition does not negatively affect surrounding infrastructure. A compilation of bridge demolitions by Controlled Demolition Inc. often highlights the impressive scale of these operations. Massive concrete spans, steel truss bridges, and aging highway overpasses collapse in a matter of seconds after standing for decades. Fire. Viewers can see the precision timing of the blasts as sections of the bridge fold, drop, or tilt exactly as planned. The dramatic visuals demonstrate the careful engineering that lies behind each explosion. In many cases, explosive demolition is chosen because it is faster and more efficient than traditional dismantling methods. Taking apart a large bridge piece by piece can take weeks or months, while a controlled explosion can complete the main structural removal in seconds. This efficiency is especially valuable in urban environments, where minimizing road closures and traffic disruption is critical. However, the work does not end after the explosion. Once the bridge collapses, demolition crews move in to clear debris, recycle steel, break down concrete, and prepare the site for future construction. Many demolition projects are part of larger infrastructure upgrades, where old bridges are removed to make way for safer, stronger replacements. Overall, bridge demolition using explosives represents a remarkable combination of engineering, safety planning, and precise execution. The projects carried out by Controlled Demolition Inc. illustrate how modern demolition techniques can remove massive structures quickly while maintaining strict control over every stage of the process. Controlled Demolition Inc. carried out the explosive demolition of the Westchester Plaza building in Fort Worth, Texas on March 18, 2018 at 8 a.m. Acting as the explosive subcontractor for Dallas Demolition Company, the company carefully prepared the 12-story reinforced concrete structure for a controlled collapse. Engineers strategically placed explosives to ensure the building fell safely within its footprint. The operation demonstrated precise planning, technical expertise, and strict safety measures to protect nearby structures in the surrounding area. In June, a carefully planned blast marked a decisive milestone at the Vama hydropower plant. AF Group detonated 10 tons of explosives in a single, controlled operation, completing the final blast of the project. The event closed a critical construction phase, reshaping solid rock with precision and engineering discipline. The demolition of the Saginaw Plaza Hotel marked the end of a long-standing structure through a classic ball and chain operation. A lattice boom crawler crane was fitted with a massive steel wrecking ball, delivering controlled kinetic impacts to fracture the reinforced concrete frame. Each calculated swing-targeted structural columns and floor slabs, progressively destabilizing the load-bearing system. Dust suppression crews maintained site control, while debris was sorted for recycling. Precision timing and crane coordination ensured the collapse advanced safely, section by section. In the Green City district of Zurich, a controlled demolition operation, Ruckbau Green City, unfolds with mechanical precision. Towering above the structure, a hydraulic demolition excavator is equipped with a colossal concrete crusher. The shear alone weighs 12 tons, a massive steel attachment engineered for structural dismantling. As the jaws close, reinforced concrete fractures under a maximum biting force of 545 tons, cracking slabs and crushing columns with calculated efficiency. When fully engaged at peak hydraulic output, the system can generate up to 500 tons of crushing force. Steel rebar twists and yields, concrete collapses in controlled sections, and debris falls within predetermined zones. During structural dismantling, water spraying plays a critical environmental control role. High-pressure misting systems are deployed around the demolition zone to suppress airborne particulate matter generated as concrete fractures and masonry collapses. As hydraulic crushers bite into reinforced slabs, fine dust, cement particles, silica, and micro-debris would otherwise disperse into the surrounding air. Each bite reduces the structure safely, preparing concrete and steel for recycling within Switzerland's advanced urban redevelopment cycle. Two green giants dominate the scrapyard floor, a pair of Senebogen 825E machines armed with heavy-duty grapples, working in tandem against a retired yellow school bus. Fitted with a robust Bateman mag grab, the setup transforms a once rigid transport vehicle into a demonstration of controlled industrial force. The Senebogen 825E, a dedicated material handler with elevated cab and optimized reach geometry, positions itself with calculated precision. Its hydraulics deliver smooth, high-flow power to the Bateman mag grab, a hybrid attachment integrating a heavy-duty grapple with a high-strength lifting magnet. The grapple's reinforced tines clamp down first, crushing side panels and fracturing window frames. Immediately after, the magnetic plate energizes, securing loose steel sections for controlled lifting and separation. One handler stabilizes the rear section, while the other clamps onto the bus body. Hydraulic cylinders extend with steady pressure, and steel tines bite into the roofline. The structure flexes under torsional load, window frames shear, riveted panels tear, and the sidewall collapses inward. Dust rises as the rear compartment peels away from the main frame. The magnet component secures loose ferrous fragments, preventing scatter and enabling efficient material sorting. Axles and heavier structural members remain briefly intact before yielding to repeated gripping and lifting cycles. What appears chaotic is in fact systematic dismantling: grip, lift, twist, separate. Within minutes, the bus is reduced to segmented scrap, ready for downstream processing. The pairing of Bateman's MagGrab and the Senebogen 825E illustrates how hydraulic leverage, attachment engineering, and operator control converge to maximize recovery efficiency in modern scrap operations. The Nye 200 is engineered specifically for automotive engine recycling applications. Designed to fracture engine blocks efficiently, the unit crushes cast assemblies into manageable fragments, enabling rapid separation of ferrous and non-ferrous materials. By breaking engines into smaller sections, iron and steel components can be extracted using magnetic systems, while aluminum is isolated for secondary processing. This mechanical segregation method reduces reliance on large-scale scrap shredders, lowering operational costs and energy consumption. Built for durability and attachment to compatible carriers, the EBC 200 enhances productivity, streamlines material sorting, and improves overall recovery rates in recycling facilities. In modern salvage yards, speed and precision define profitability. Mounted on the agile Volvo EC160, the USA-patented SAS Extreme Auto Processor turns end-of-life vehicles into high-value components within minutes. This engineered grapple system allows operators to process cars, trucks, and SUVs in under 10 minutes. Radiators, condensers, EQ modules, AC evaporators, engines, transmissions, and copper wiring are extracted systematically before the remaining shell moves to shredding. Designed for auto recyclers, wreckers, and salvage yards, the attachment maximizes material recovery, reduces manual labor, and accelerates throughput. Export availability expands its reach to global scrap markets. The RG's VZ950 stands among the largest and most powerful hydraulic shredders in heavy-duty recycling. It represents the upper tier of industrial size reduction technology. Designed for extreme-duty applications, the VZ950DK delivers immense torque through its dual-shaft system, enabling efficient car shredding and processing of bulky scrap metal. When end-of-life vehicles enter the hopper, hardened steel shafts rotate in opposite directions, gripping, tearing, and fragmenting the structure with controlled hydraulic force. Body panels collapse, frames twist apart, and engines are broken down into manageable fractions. The machine's slow-speed, high-torque principle minimizes dust and vibration, while maximizing throughput and material recovery. For operators facing demanding shredding tasks, whether automotive scrap, mixed metal, or heavy construction debris, the VZ950DK offers industrial-scale performance, durability, and precise output control. At a busy scrapyard in Spain, a massive industrial press descends with deliberate force. The steel jaws of the aplastadora clamp down on a worn-out passenger car, flattening decades of metal, rubber, and glass into a compact slab. Panels buckle, the roof caves inward, and the chassis folds under hydraulic pressure measured in tons. Within seconds, what once carried families down highways is reduced to recyclable scrap. This controlled destruction is not chaos, but precision engineering, efficient material recovery, volume reduction, and preparation for melting, where crushed steel will re-enter the manufacturing cycle as raw industrial feedstock. R5 is a hydraulic car baler engineered for high-density compaction of end-of-life vehicles. The machine features a reinforced compression chamber constructed from wear-resistant steel, designed to withstand continuous impact loading. Its asymmetric hydraulic cylinders generate high pressing force, ensuring uniform material densification and stable bale geometry. The compression box produces standardized bale dimensions optimized for downstream shredding and transport efficiency. Designed for ground-level installation without complex foundations, the RR5 integrates structural rigidity with service-accessible components, minimizing downtime and simplifying maintenance in demanding scrapyard environments. In 1960, the Boeing 707 became a flagship of Lufthansa, symbolizing the dawn of intercontinental jet travel. For 15 years, it operated scheduled routes linking Tokyo, Sao Paulo, and San Francisco before retiring to Hamburg. Decades later, this aviation icon met a different kind of precision engineering. Equipped with a KDS-50 diamond saw, a Chemrock cutting system methodically sectioned the historic airframe. Controlled diamond wire technology ensured accurate segmentation, transforming a legendary aircraft into carefully dismantled structure, where aerospace heritage intersected with modern demolition capability. At the recycling facility of EWS, the EcoMax 800 transforms bulky end-of-life tires into manageable, high-value secondary raw materials. Every day, passenger car, truck, and even massive agricultural tractor tires arrive, dense, elastic, and notoriously resistant to mechanical stress. Engineered for powerful primary shredding, the EcoMax 800 utilizes asynchronously rotating paddle shafts to grip, tear, and pre-shred even oversized tires with controlled torque. The aggressive cutting geometry breaks the tire structure, separating rubber from embedded steel reinforcement while dramatically reducing volume. The result is efficient material conditioning for downstream processing, whether granulation, steel recovery, or energy applications. High throughput, durability, and consistent output make this system a cornerstone of modern tire recycling operations. In high-volume tire recycling, efficiency is not measured by speed alone. It is defined by continuous flow, operator ergonomics, and the elimination of every unnecessary movement. The inclined tire baler conveyor feeding 2 Mk2 balers creates a continuous, non-stop tire processing system engineered for efficiency. A high-capacity hopper stores up to 600 tires, while modular side panels adapt to multiple loading methods. Tires are delivered directly to the work zone, eliminating wasted motion. When compression is complete, the platform slides back to discharge finished bales quickly and safely. Foreign rock saws integrate advanced hydraulic systems, high-quality imported motors, spring steel, and synthetic diamond segments to deliver safe, reliable, and cost-effective cutting performance. Adaptable to 3 to 45-ton excavators, they offer flexible installation and low maintenance. Applications include demolition, highway works, basement and concrete cutting, trenching, quarrying, and tunnel excavation. Diamond wire technology has become deeply appreciated in the stone industry for its precision, efficiency, and material preservation. Engineered for cutting granite, marble, and reinforced concrete, diamond wire delivers controlled separation with minimal vibration and reduced kerf loss. Unlike traditional blade systems, it enables complex profiling and large section cutting while maintaining structural integrity of the block. The production of diamond wire is a highly technical process. High-tensile steel cable forms the core, ensuring flexibility and tensile strength under continuous load. Sintered diamond beads are manufactured using carefully graded synthetic diamonds embedded in a cobalt or metal alloy matrix. These beads are then crimped or molded onto the cable at precise intervals, separated by injection molded spacers that control alignment and wear distribution. Quality control includes tensile testing, bead hardness verification, and concentricity inspection to guarantee uniform cutting performance. The result is a durable, high-performance cutting system designed for high-stress quarry and fabrication environments. In gypsum mining operations, the Chemrock EK140 delivers controlled, vibration-reduced extraction. Engineered for precision cutting, the chain cutter fractures soft to medium-hard material with consistent depth and clean profiles. Mounted on hydraulic carriers, it ensures efficient material removal, minimal overbreak, and optimized productivity in selective mining environments. Designed for plate lip applications, the Z-tooth system maximizes penetration with a self-sharpening edge and optimized wear ratio for extended service life. A pre-installed metal retainer, poka yoke locking hole, and hammerless system ensure secure, fast maintenance. Reinforced adapters with symmetrical load distribution enhance durability, delivering predictable uptime and superior digging performance in extreme mining conditions. At the Bulletin Itique open-pit copper mine, large-scale material movement is driven by the Caterpillar 795F, operating in coordinated cycles with high-capacity electric rope shovels from P&H Mining Equipment. The 795F, engineered for high payload efficiency, transports blasted ore and overburden across long-haul routes under continuous production demands. Its high-horsepower diesel engine, Advanced braking systems and reinforced frame are designed to withstand steep gradients and abrasive Nordic conditions. Loading operations are executed by P&H rope shovels with precise bucket control and optimized pass matching, reducing cycle times and maximizing fill factors. This integrated fleet configuration ensures consistent productivity, fuel efficiency, and structural reliability within one of Europe's largest copper mining operations. With the arrival of spring, construction sites accelerate, and so does the demand for efficient waste processing. The Compactor 300 is engineered to transform mixed construction and demolition debris into valuable secondary raw materials. Through its powerful twin-shaft shredding system, bulky waste streams are reduced with controlled torque and consistent particle sizing. Today, up to 90% of C&D waste is reprocessed for recycling, and this machine forms the mechanical backbone of that recovery cycle, delivering throughput, durability, and reliable material conditioning. For more than a century, the gyratory crusher has stood at the heart of primary crushing. In its hydraulic form, that legacy evolves into a machine built for scale, stability, and control. Uniform product sizing, reduced liner wear, and production rates up to 4 times higher than jaw crushers define its performance. Hydraulic cone support and energy storage systems absorb overloads and fine-tune the discharge opening with precision. This design simplifies material handling, reduces auxiliary equipment, and makes the hydraulic gyratory crusher the preferred solution for large and medium-scale mining operations processing hard rock. Strobel manufacturing HD scraper and dual packers redefine earth-moving efficiency. By integrating a 20-foot heavy-duty box scraper with a high-performance packer, grading and compaction occur in a single pass. Reinforced welded sidewalls ensure durability, while fold-in tongue and axles simplify transport. The packer's hardened teeth and hydraulic lift wheels deliver targeted, high-density compaction. Fewer passes translate into measurable savings in fuel, labor, and overall cost per cubic yard. Witness the SW450 swing wheel low loader in full operation, purpose-built for extreme heavy haul performance. Rated for payloads up to 450 tons, its hydraulic swing arm wheel system lowers the deck close to ground level, enabling efficient loading of massive mining trucks and tracked equipment. Once secured, the wheels pivot back into transport position, optimizing stability and weight distribution. Oil-cooled braking systems ensure controlled descents under load, while the reinforced chassis withstands severe site conditions. Every movement reflects engineered precision, power, and uncompromising transport reliability. Land preparation for agricultural development in South Africa demands high tractive effort and structural durability, capabilities delivered by the Komatsu D275. This large crawler dozer is engineered for heavy-duty earth moving, making it ideal for clearing vegetation, removing stumps, and leveling uneven terrain prior to cultivation. Its high-horsepower engine and torque converter transmission provide consistent pushing power across compacted soils and mixed ground conditions. The wide blade ensures efficient material displacement, enabling rapid grading and contour shaping. Reinforced undercarriage components enhance stability on loose or abrasive surfaces. With precise blade control and robust hydraulic response, the D275AX establishes uniform field profiles, creating a stable foundation for irrigation systems, planting operations, and long-term farm productivity. At a national field demonstration near Ravensburg, the Swiss-based Brielmeier Motor GmbH introduced its new product line for wet meadow management. The platform utilizes wide-track or dual-wheel configurations to distribute weight evenly, allowing safe operation on saturated, load-sensitive substrates. Its double-knife mowing system delivers a scissor-like cutting action that reduces energy consumption while producing a clean, low-impact cut. Unlike rotary systems, vibration and suction effects are minimized, preserving root systems and microhabitats. Hydrostatic drive control ensures smooth torque transfer and stable traction, even on uneven, waterlogged terrain. The result is advanced ecological land management, maintaining wetlands and marshes with maximum surface protection, reduced biodiversity loss, and consistently high operational efficiency. When payload density rises and abrasive material pushes equipment to its limits, only a purpose-built hauling solution can maintain structural integrity under extreme demand. The MBD 100, configured for the CAT 775 grams, represents a genuine mega design in bottom dump trailer engineering. Built for high-density abrasive materials, the mega bottom dump platform is structurally optimized to withstand severe haul conditions while maintaining compliance with OEM tire ratings and tractor axle load limits. The design aligns with ROPS, emergency steering, and braking performance requirements, ensuring operational safety under full payload. The MBD 100 delivers seamless integration, balanced load distribution, and long-term durability in demanding mining and bulk earth-moving applications. Cortland, in collaboration with Caterpillar, developed plasma synthetic rope tow lines engineered for demanding mining and off-highway recovery operations. Delivering comparable strength at roughly 1/7 the weight of traditional steel cable systems, these assemblies significantly reduce handling risk and improve deployment efficiency. Designed with operator safety as a priority, the rope dissipates energy by separating without dangerous recoil if failure occurs, minimizing backlash hazards. Unlike metal alternatives, synthetic fiber construction resists corrosion, does not rust, and avoids fatigue caused by prolonged environmental exposure, ensuring long-term durability in harsh field conditions. At the dynamic heart of the port, a monumental logistics operation unfolds as Ferrovial undertakes the transport of the colossal Komatsu 4800 XPC to Minera Escondida. This ultra-class electric rope shovel, engineered by Komatsu, represents one of the most advanced loading platforms in modern mining, designed for maximum productivity, structural endurance, and high-capacity material handling. Each oversized component is carefully lifted, secured, and positioned onto specialized multi-axle transporters selected for extreme load ratings and stability control. Route planning, axle load distribution, and maneuvering clearances are calculated with precision to ensure safe passage from port infrastructure to the arid mining corridors of northern Chile. The convoy advances methodically, transforming highways into a coordinated stage of engineering choreography. This operation is more than heavy transport, it is the physical movement of innovation. As the 4800XPC approaches its destination, it carries with it the promise of higher efficiency, greater output, and a new chapter in large-scale copper extraction. At the HS2 trial site, concrete canvas was evaluated as a high-performance alternative to traditional in-situ concrete channel lining. The installation demonstrated multiple deployment techniques, including 3-wide longitudinal placement for continuous runs, corner transverse deployment to accommodate directional changes, and straight 3-wide transverse installation for wider sections. Once positioned, the material was securely fixed and fully hydrated, activating the cementitious layer. Following curing, controlled backfilling completed the system. Engineered for rapid construction, concrete canvas can be installed at rates of up to 2,000 square meters per day, with deployment speeds exceeding 400 square meters per hour. The material offers uniform thickness, reliable surface integrity, and effective weed suppression, reducing long-term maintenance requirements. Installation is achievable in varied weather conditions, minimizing program delays and lowering overall project costs. Environmental performance is a defining advantage, delivering approximately 55% reduction in embodied carbon compared to conventional concrete lining. Fewer vehicle movements and reduced channel preparation further decrease site impact. Manufactured in the UK and designed for a 120-year service life, the system provides a durable, low-carbon solution aligned with modern infrastructure standards. A Flanders dragline upgrade enhances the performance and reliability of giant electric cranes used in surface mining. These massive machines operate as electrically powered heavy equipment, designed to remove and relocate enormous volumes of overburden in open-pit operations. The dragline features a towering steel lattice boom and a large bucket suspended by cables, enabling it to excavate and cast material across significant distances. Structural reinforcements and modernized control systems improve efficiency, reduce downtime, and extend service life. In large open-pit mines, upgraded draglines remain essential for high-volume earth-moving productivity. In the Northeast, Willow Tree operates a high-efficiency power screen crushing train engineered to process limestone with precision and consistency. Supplied by Blue Group, the system begins with a PT400 jaw crusher, delivering reliable primary reduction from blasted rock. Material is then screened by a Warrior 1800 to control feed sizing, before entering the 1000 Max Track cone crusher for secondary and tertiary shaping. Final classification is handled by 3 Chieftain 2100X screeners, producing tightly graded end products to specification. Designed for continuous operation, the crushing train combines robust throughput, controlled material flow, and flexible screening capacity, supporting WillowTree's demand for high-quality limestone across multiple construction and aggregate applications. Poured and asphalt is laid, everything begins with the quality of the sand. At this production site, manufactured sand is engineered, not improvised, through a tightly controlled crushing and shaping process built around advanced SPM technology. The system combines a VSI 5X series sand making machine with an HPC series multi-cylinder hydraulic cone crusher, forming a high-performance circuit designed for consistency, efficiency, and industrial scale output. The process begins with primary and secondary crushed material entering the HPC cone crusher. Its multi-cylinder hydraulic system delivers precise crushing force, stable operation, and automatic overload protection, producing a well-graded intermediate product. Real-time hydraulic adjustment allows the discharge setting to be optimized under load, ensuring uniform particle size and reduced liner wear. This controlled output is critical for downstream sand shaping. Material then flows to the VSI 5X sand making machine, where high-speed rotor technology accelerates stone against anvils and material beds. This impact-driven mechanism refines particle shape, increases cubicity, and removes weak edges, producing sand that meets strict concrete and asphalt standards. The VSI 5X design also incorporates optimized feed distribution, wear-resistant components, and efficient airflow management to maintain stable production. Throughout the site, conveyors, screening units, and dust control systems are synchronized to maintain continuous operation. Automation links crusher performance, sand quality, and throughput into a single production logic, reducing manual intervention and energy consumption. Together, the HPC cone crusher and VSI 5X sand making machine form a modern manufactured sand solution capable of delivering high output, superior particle shape, and reliable long-term performance for large-scale aggregate and infrastructure projects. Engineered for high throughput efficiency, the 700 TPH iron ore wash beneficiation plant in Australia is built around a robust, process-driven layout. The M4500 wash unit performs precise washing and cut sizing at 5/32 inch, preparing material for downstream separation. The lump ore circuit applies jig-based gravity separation, paired with high-capacity dewatering screens to ensure effective moisture control. 17 static and radial conveyors maintain uninterrupted material flow across the site. In the fines circuit, cyclones remove slimes before spiral separators recover valuable fines through density-based separation. Two A1500 systems close the loop with advanced water recycling and sludge management, ensuring operational stability, reduced water consumption, and consistent product quality at scale. The Menzi Muck M545, paired with a Cerruti Big 620 snow clearing attachment, becomes a versatile winter workhorse. Its adjustable hydraulic legs and articulated design let the machine stabilize on uneven ground, while the big 620 high plows, lifts, and pushes heavy snow with efficiency. The high-flow hydraulic system drives the snow blades smoothly, clearing roads, ramps, and yards. This combination delivers precision, traction, and reliability for demanding snow removal operations in alpine and urban environments. When snow threatens operations at Minneapolis-St. Paul International Airport, a meticulously coordinated response moves into action. More than 28 million square feet of pavement must remain operational, demanding precision, speed, and seamless communication. Led by the Metropolitan Airports Commission Airside Operations Department, pre-storm briefings align airlines, the Federal Aviation Administration, and the National Weather Service to assess timing, intensity, and runway strategy. Once activated, over 100 personnel deploy a fleet of 150 specialized machines. Runways close briefly, often just 15 to 20 minutes, while coordinated conga lines of plows, brooms, blowers, de-icers, and sanders clear snow in synchronized formation. Friction testing vehicles verify surface safety at operational speeds before reopening. Electricians clear runway lighting by hand, while high-capacity snowmelters process up to 150 tons per hour. Even after snowfall ends, crews remain vigilant. Through relentless execution and engineering discipline, aircraft continue moving safely despite severe winter conditions. Tunnel fires escalate rapidly, driven by confined geometry, high thermal loads, and restricted evacuation routes. Early detection and immediate suppression are decisive. The stationary 1-7 CAF system intervenes within critical minutes, delivering high-performance compressed air foam before fire brigade arrival. The system generates highly adhesive foam that clings to walls and ceilings, protecting structural linings while suppressing flames across diverse fuel types and flammable liquids. Activation is controlled centrally or locally, ensuring operational flexibility. Engineered for various tunnel lengths and cross-sections, the dry pipe configuration with remotely actuated valves minimizes maintenance. Integration with 1-7 hose lines enhances defensive firefighting capability and supports extended tunnel use, including heavy and hazardous transport corridors. Third and 11th Streets is being reconstructed using precast concrete pavement panels, the first application of this method in Indiana. The system reduces pavement depth and avoids conflicts with underground utilities. Removable, replaceable panels accelerate construction, simplify future utility access, minimize maintenance disruptions, and extend overall pavement service life. Steel rails stretch toward the horizon, but renewal begins long before the first sleeper is lifted. The P95 Matissa track renewal train advances along the existing alignment, like a mobile production plant, transforming worn infrastructure into a fully rebuilt track while preserving the original geometry. Often described as a factory on wheels, this integrated system performs each operation in a continuous, synchronized sequence, frequently described as a factory on rails. The system advances along the line scheduled for replacement and leaves behind a fully renewed track structure that respects the original alignment, gauge, and longitudinal geometry. The process begins with the fastening removal unit. Clips, anchors, and associated components are disengaged methodically to free the rails without disturbing the underlying formation. The old rail removal module then lifts and guides the rails away from the track axis, transferring them to dedicated handling wagons. A fastening pickup unit follows, collecting residual hardware to maintain a clean and controlled workspace. At the core of the consist lies the primary working group. Here, worn sleepers are extracted in sequence. Hydraulic gripping and lifting mechanisms ensure stable handling while maintaining track geometry control. Once removed, ballast leveling equipment reprofiles the ballast bed. This stage is critical. It restores the design crossfall and longitudinal profile, ensuring uniform load transfer and preparing a stable platform for the new track components. New sleepers are then laid with precise spacing and alignment. Automated placement systems maintain consistent center-to-center distances, preserving gauge accuracy. Immediately afterward, rail insertion units position new rails directly onto the sleepers. The geometry is continuously monitored, allowing corrections in real time as the train advances. Fast clip insertion systems secure the rails to the sleepers with calibrated clamping force. Automated modules such as PMP1, PMP2, and P2R coordinate material logistics, distributing components efficiently and preventing workflow interruptions. Where localized intervention is required, a cutout function enables selective replacement of defined sections without affecting adjacent track. Throughout the operation, integrated measurement and control systems supervise alignment, cant, and gauge. This ensures that the renewed track retains its initial geometric parameters, minimizing the need for extensive corrective tamping after installation. The continuous workflow significantly reduces track possession time compared to conventional renewal methods that separate removal and installation phases. The P95 Matissa configuration demonstrates how mechanized railway engineering achieves high output with controlled precision. By integrating dismantling, ballast preparation, sleeper installation, rail positioning, and fastening into one coordinated pass, the system delivers structural reliability and operational efficiency. The outcome is a renewed track structure ready for stabilization and return to service within tightly managed timeframes, an essential capability for modern rail networks. The Medium Ground Mobility System, featuring the M30H Trackway Medium Beam Dispenser, delivers rapid ground stabilization in the most demanding environments. Designed for military and heavy logistics operations, the system deploys continuous aluminum track panels that create an instant roadway over sand, mud, marsh, or unstable terrain. Mounted on a compatible support vehicle, the medium beam dispenser unrolls and retrieves the M30H trackway with controlled, hydraulic precision. Within minutes, soft ground is transformed into a load-bearing surface capable of supporting armored vehicles, supply convoys, and heavy equipment. Engineered for durability and repeated deployment cycles, the aluminum panels provide high traction and structural strength while remaining lightweight for transport. The result is enhanced operational mobility, reduced vehicle bogging risk, and sustained mission tempo in austere or rapidly changing ground conditions.